Welcome to Tinker's Lab. Yeah, I've been tinkering, I have, with old Henry's heart. Yeah, in the form of the motor, which has been sparking like Billy-O and no power. Pretty much, you know, there's just lots of sparks, smells, and it's pretty nasty, but no, very little power. Now, I've tried all sorts of things, including testing the motor before, but I was using an automatic meter, which is not a great idea for this job. So I've managed to dig out a manual digital meter, and what we're going to do is we're going to test the armature for continuity. So it's ever so easy to do. All you want to do is grab yourself a couple of crocodile clip patch cables like these ones here. All right, stick one on there, all right, and one on the opposite brush on the other side, and then we've got contact with the brushes themselves. But I'll put it on there. That might be better. Okay, so each side of the armature and the commutator, effectively, as the brushes make contact with the commutator, which has all these little copper strips, effectively they are the contact points for the brushes, and it creates a circuit. Okay, now if you count all those little copper lines on your commutator, then half it, you'll know how many circuits you've got, generally speaking. Some of it's different, obviously. Now, this is quite a basic little motor. 230 volt, I think about 1000 watt. And the commutator in there is very badly worn. The brushes are in a bit of a state. So you really, the bare minimum it needs a new set of brushes, really, and holders. Because what I've noticed is the actual brushes weren't sitting true with the commutator. So I've sanded them flat, just a bit of an experiment. And I notice also that the brushes are not worn on the sides, so effectively they rattle about a bit inside their little holders. They can't be tight, obviously, but they have to be able to be free moving, but not that loose. Because they're that loose, there's a weird clicking noise going on where the brushes are effectively falling into the slots. I don't know if you can hear that. Da 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 da. People, I don't know if you can hear that. Da, 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 da. Clicky noise, right, inside the motor. So I had to speak what I'm doing because obviously the limiter on the microphone doesn't turn off. Now, not limiter, the noise reduction, because it's such a low sound. So what we're going to do is we're going to test them, all right? So we know that the brushes aren't making very good contact anyway. We know that because we can hear it, quite frankly. And then there's sparks flying off everywhere. And I'll demonstrate that at the end of this video. Okay, just so you see. But I've got the meter here. I'm going to move you over to the overhead camera. I do like the play idea. You might have noticed, yeah. All right, there's the meter, okay? For you, it's the wrong way around. Let's put it that way up. I need to spin that camera around. There you go. Like so, all right? What I'm going to do is I am going to turn this around, and we need to look at the continuity between and the ohmage between each of the contacts. Every time it makes a contact from one side of a circuit to the other, there is going to be a reading. Well, there would be if I connected it properly. All right. Let's bring it over. All right. Oh, there we go. So we've got a reading. So no reading basically means we're in between. Okay? Can you see what's going on here? That should be very slight. Now, every time I turn it, it says 4, 1. There's quite a variation going on here, which tells me the contacts are not very good. 3, 4, 2, 1, 0. I'm looking for gaps as well. If there's a gap, the likelihood is one of the coils are gone. One of the circuits have burnt out. Oh, that might be gone. Oh, clicking like crazy. You might not be able to hear it because the microphone might not be picking it up. There we go. Now we expect around between on the setting I've got on this particular little meter. I'm not going to say it's a particularly accurate meter. It's a very cheap meter. I'm on 200 ohms. Nano. There we go. I'm on basically the lowest setting. 9.6. Oh, crikey. Yeah, this isn't very good. Now, it could be that the brushes aren't making very good contact. Now, if I could actually take this apart without causing any further damage, I could then put the actual contacts, the probes, on either side of the core of the armature on each contact. And if I've got a similar problem and not getting good continuity, well, then obviously there's a problem in that circuit. At the moment, some of the problems I'm getting could be the brushes themselves. Well, that wasn't a very good one. No, it's not. Skipping. So, what this is showing me is whether or not there's a good contact between the brushes and the actual motor. Now, I just noticed something, okay? Now, I don't think it's meant to be like that. I noticed that the brushes are actually angled at the moment. I don't know if you can see that. Let's remove that, right? Remove that. That in line with the armature. No wonder those brushes are wearing at an angle. Stands to reason, doesn't it? Interesting. I don't think it's meant to be. Now I can see the brush there making contact, but it's loose. It's moving around in the holder. It's like the sides of the brush have been badly worn. As you see, the comm is a bit burned. It's been getting a bit hot. Not in very good condition at all, in fact. See, he's on that side there. Yeah. So let's test it. Should we try it? Right, let's take it off the old meter. Let's put some power through it, shall we? Yeah, let's get dangerous. Right. Now, I've got a very dangerous fly lead over there, for which we're going to connect this one. See? Oh dear. So we're going to connect that to there like so. Don't try this at home, ladies and gentlemen. And then connect that one there like that. Oh, it's not turned on at the moment. It's on a switch, so we can turn that on. Then I'm going to make sure there's nothing in the way and that we hold the motor down. I'm just using a wooden handle like that. So I'll put that on there like that to hold the motor down. And we'll see what sort of shit that's going on with this particular motor. Alright, you might have seen it in previous videos, but... Oh, hold it now. As you can see, it ain't very happy. And let's turn it around the other way so you can maybe see a little bit better. I'll hold it like that, hopefully. What makes you see it? There you go. We'll try it again. It's better. I think I got it. Let's make sure we can get you in there. That's it, about there. Ready? There we go. Oh, something's happened. Something's happened. Come off. Right, let's try again. No, it's stud. Oh dear. Not happy, is it? Right, so it's decided that it's not having it. It's not having it. No. Let's put that on there like so, make it a bit tighter. Shit, that didn't do what say on it, does it? Let's try again. You stay on there. And you stay on there. Right, that way round first. Nope, it's not having it. Let's just grab the meter, put it on to volts. Let's make sure we've got voltage. Might just be a supply problem. Turn it on. We've got voltage. The motor is shagged. Oh, what fun. Right, let's put that back onto the blue. What would have been the blue? Really needs a new motor. Let's put that back onto there. We know we've got voltage there. Brushes doing nothing. It only takes one brush not to be making contact. Okay? It might be stuck inside his hole. Got a sticky brush, that'll cause that. Oh, there you go. We've got a sticky brush problem. So, new brushes would definitely help. Let's see whether or not we can show you what's going on in there. Bring it down a bit. Let's make sure you're focusing. Let's put it onto autofocus briefly. Go. Oh, strange. Right. We'll try again. Hold it there like so. Let's turn it on again. Hopefully you're better to see that brush contact. There you go. There's the brush. Nope, doesn't like it. It don't want to be on the side, does it? Why is that? Strange. What if I turn it around a little bit? Maybe it's that brush. It's not been sprung into place. Let's turn it around. There's actually... Don't know which brush is sticking, but one of them is. Not a happy bunny, is it? No. Do you think it might be a goner? I think it might be a goner. I don't think it's really worth worrying about, really. So I think it needs a new, it needs a new motor. Now I have to ask myself, is it worth it? Or can I buy a cheap vacuum cleaner that has the same motor inside? Is there one for, you know? Because these are quite a generic motor, these are. See, these on quite a few different vacuums. It's like they've been copied. Yes, I'm removing the fly leads. I don't want to leave two bare wires dangling about. I'm going to use next. That's what I'd laying about. I know I have a longer one here, but I can't find it. I'm in a bit of a mess, you see. That I am. Anyway, so I think what we're going to do is we're going to relegate that and try and get hold of another motor for the right money. Or there's no point spending all the money on a vacuum cleaner that's 28 years old and it's got other problems as well, like the handle's broken and stuff like that, you know. And then spending on 40, 50 quid on a new motor doesn't make sense. Possibly not. So until I can find one, and one comes up for the right money, or a Henry comes up for sale for like 30 quid or something stupid, which it does happen, I'm going to, well then you probably just, if it works, you probably just leave it alone, wouldn't you? Just carry on using it, just to make sure everything's working on it. I might just try a set of brushes in there, just to Might give it a go. We'll see. We'll see. Anyway, hope you enjoyed that. That was a bit of fun, I suppose. Toodaloo. Don't forget to beat the old like button.